data, you can think like any data out there on the internet is used to train the large language models. And when we really look inside these models, it's really like a neural network that has billions, and sometimes like we're even moving towards trillions of tokens, or nodes in this case, and they can scale to do really general purpose sort of, tasks for us. And they actually have a lot of versatility in terms of the tasks that they can do. We can ask them to, generate code. We can ask them to do art. We can ask them to do, write poems for us, basically anything and everything out there. So modern LLMs can do these different tasks without any specific training. Because of the data that they have seen, they can actually produce fairly reasonable output based on the training that they have. And in terms of some of these capabilities, these days we are starting to see things like reasoning is getting added to the models. We can also see like large language models where primarily had a cutoff date. For example, they could actually nowadays they can actually do search, get real-time data from the internet and augment it. Even if they do have a cutoff, they can augment the response so that they will provide. And other, key factor to understand when it comes to LLMs is that they do have like a fixed content, which means they can only remember your conversation a certain point after which the context is gone. Like it's called a rolling window in terms of context, and it keeps rolling off. And when you can, and that is where you can start seeing the responses deteriorate. So maybe you have tried, generating code, and after maybe 30 minutes, it is completely off, and that is basically when the context window is gone. So the model is no longer, responding. So how do these models really work in terms of actually building these LLMs? There is a process named pre-training. LLMs really, what they're really good at is predicting the next token. Token in this case is not something related to security. It's basically predicting the next word. And you can think of a token being, a portion of a word or portion of a sentence as well. And that is why, really large language models are strong. Even though they are language models, they don't really understand text though. And computers work with numbers. So we do have to find a way to translate all of these text into numerical values. And we do have to bring in syntax and context into those numbers. So, for example, if we want to think about English language, English has like 600,000 words in the English dictionary, and each of them needs to be translated into a token. The way that these tokens work is that each word is assigned a number, and you can think of this as very fundamental, where each word is getting a number, and then large language models are trained based on those numbers. They are fed these chunks of data, and they keep seeing patterns. They start learning those patterns, and then they will be good at predicting the next token based on the patterns that they have seen before. So you can also do fine tuning with LLMs, which is what we will cover today. And what it really does is that it helps these large language models adapt to specific tasks. Um, or if you want to give your LLM a specific personality, or if you want to make it aware of a certain domain, whether that's healthcare or financial services or manufacturing, etc., you can actually train these LLMs using that data. And the intent is, when you look at what the work that's being done in industry, you know that you know how these models can be helpful, so they can act like an assistant, and you can ask any questions that you want from these LLMs. And the inference is actually when we generate different responses to the user prompts. Um, so when we really look at these inside these LLMs, and what we will see is that basically there are two files that make up an LLM, and this is an oversimplification, of course. But you really, you will end up with a parameter file, which you see here in the diagram on the right, and the parameter file basically is where the parameters for neural network are actually defined. So these are, the weights that are defined and the biases values that are defined in the neural network. And then you really have a small, runtime. So this is the program that basically runs. And when you look at any other, popular company like OpenAI or Anthropic or Google, what they really do is they put an API in front of their runtime and basically expose that API where you can query and ask questions, um, and get answers by querying the runtime, which talks to the parameter file. So the question is, how do we get this parameter file? And the way to get it is through a process called, as we said, pre-training. And this really involves taking a huge chunk of the internet and really running it through the pre-training process. And that is where a large cluster of GPUs come into the picture. And in some cases, these are, running hundreds of thousands of GPUs, and the pre-training process can run for several weeks. And then we will have what we call the base model. It is a process that is very compute intensive, very expensive, and which is why very few companies can afford to do really good base models because of all the hardware that is needed in this process. Now, if we want to look at some of the core capabilities of LLMs, what would they be really good at? So things like whether it is creative writing, whether it is being able to generate code, whether you want to do some sort of get using conversational aspect of the LLM. So this is where the concept of assistant models come into the picture. We have pre-trained model. Generally, what happens is that we have like some human beings, and they basically write up different sample conversations, and then they use that conversation to train the model, to build actually an assistant model. So if you look at ChatGPT or any of the mainstream models that you can converse with, they basically have some pre-training, and that's being created by human beings that's fed to these models, which can make them, really helpful assistants. Now, this LLM technology is evolving at a, very, rapid clip. It does have, some limitations though. And as we speak, some of these are being overcome. But I think the number one problem with almost every model out there, it is hallucinations. Since a lot of these models will do prediction in terms of the next token, we should remember that they are probabilistic rather than deterministic. When we look at most computer systems, whatever we are building using, traditional programming or development, most of our use cases end up being very deterministic, which means if you have a standard, set of data, every time you're going to get the same output because it's deterministic. But with large language models, we should not forget that these are statistical models. They generate the output with some probability and with some confidence. So you may see, different results based on how the data flows. through the neural network, which layers and which weights are being fired inside the model. So they can also sometimes give you different responses. So that sometimes leads to hallucinations where the model might make up something, and that's just not true. A lot of the models still have knowledge cutoff, but the way they've offset this is they run when you query a lot of the modern models, for example, GPT or Claude, they can actually do a web search and try to pull the latest information. And even when it comes to some type of computational reasoning, I guess, there are, some popular posts on social media, and they're not really, factual. They use those posts as, their reasoning, but they're getting better now. And so the problem is that we are just still struggling with a lot of these issues, and it will become better over time. Um, Right. So another point to think about is the model types and categories. Uh, we have open source models. So when we look at models like, the model that OpenAI releases, like GPT OSS, we have Llama, you have Mistral. They have, both open source and closed source models. And then, there are also like Google Gemini series that we have. Open source versus closed source, they have both pros and cons, and you have to think about what you want to pick. And for many of you who are trying to use LLMs in your daily job, in upskilling your job, this is a this is something you need to consider. Do I want closed source or do I want open source? If you have an understanding of what the weights are in the model and what data was used to train the model, and that is what really makes it open source. With the closed source, they don't really share much information other than, just the API access, a key to be able to query the API, or documentation on how to call the API. So as a consumer, you really don't know what the weights are, and you have no way to change the weights of these models. And basically, you don't know what data they use to train the model. Is this good quality data? Is this bad quality data? No idea. But in open source, you have a lot of control. It lets you do a lot more customization to the model, and when it comes to, the proper proprietary models, these are very heavily funded companies, so they have a lot of resources at their disposal. You can, they find new features immediately, new capabilities rapidly. So this is one benefit you have when you go with the closed source. You can either, start hosting a standalone model, or you locally host a model, and you can either, run this on-prem or even on cloud. But you need to manage it yourself. You could, just use it like an API endpoint. And another thing that you need to consider is the cost perspective. Um, the open source models, you will see based on your scale of the industry that you are in. There is, source of where you plot your usage, maybe provide some graph or something, and you'll see that depending on your company and your use case, when you hit a certain amount of usage, the closed source models, they can get really expensive over time as you start consuming more and more tokens. And some of them even have, timeouts. And we look at, more of these decisions, how you would make in terms of selection of the model and the cost. But once you get into larger volumes, the closed source can get really expensive. So that is where you may think about, hosting your open source model. And that is where you will have just a fixed cost of the infrastructure that you're using to host the model. Um, if you have 5 million requests per day or 1 million requests per day, it's just going to do the infra cost. So that's just something that you have to keep in mind as you make this choice. Also, another thing, when it comes to size of the model, you have different sizes in terms of the number of parameters that these models have. So you can really you can have smaller models like 1 to 7 billion parameters, or medium size up to 70 billion. And then we really have really large models, and in some cases hundreds of billion and approaching to trillions of parameters. So one thing to remember in this case is that the biggest model is not necessarily the best for your use case. You should select based on the use case, the industry that you are in, the number of tokens that you need to have, and consider like an educated decision. So we look at, what are the some of the key factors when it comes to selecting these LLMs. And there are really, four broad areas or pillars you need to look at when you want to select a large language model. And it's really across, performance, technical, business, and what is really close to my heart is security. And those are really, the four areas that you need to focus when you select your LLM. Let's look at each of them one by one. So from a performance standpoint, what you really want to is how well does your model perform? And there are things like context length in terms of how much information can the model remember while you are working with it. And this can vary quite a bit. For example, Gemini Pro series model, I think it's like 2 or 1.5 Pro something, they can actually support up to 2 million tokens. So very large context window. And then there are some smaller models that only can cover like 128K, maybe up to 400K context window. So you do want to understand what the context length is based on your use case. You also want to look at how reliable and accurate the outputs of your model is, depending on your use case. Not every use case, might need reasoning capabilities. Do you want to understand, PhD level mathematics, or do you want to create a sales agent or something like this? Um, do you actually even need those abilities, that amount of reasoning? In terms of, evaluating how your model is performing, you can look at some of the and take it with a grain of salt. One of the resources is use LM Arena. It's like an unofficial benchmark, so that's something you can take a look at. Hugging Face has a great benchmark, and they have a listing of different scores based on different use cases. That one is really good to look at. And but you have to think about your own use case, because they have a data set and they have a use case and they come up with a number, but you do have to do your own evaluation in this case. The other part is the technical capability, from a technical standpoint. So you definitely want to look at the latency, because it will become really critical if you have, real-time application. If you are building a chatbot, it's a live chatbot, maybe it's for customer service. And they're keeping asking questions, that's where really, speed and response of the speed becomes critical. But if you are, doing some sort of batch processing job, where you're doing, some language document translation, something like this, you have, the speed really doesn't matter. It's okay to wait a couple of more milliseconds, right? So a lot of, these closed source LLMs, so they provide API. You'll batch, you can do batch jobs. They tend to be, if you do batch, they tend to be less expensive compared to real time or on demand. So that's something, again, if you want to make a selection, you have to think about the scalability of your job, and how often you want the result. Is it real time or not? So for different providers, whether you're going directly, to the LLM provider, whether it is, Grok or Google or OpenAI, they have restrictions on your TPS, which is transactions per second. How many requests are you going to have? How many concurrent requests are going to be submitted to their API? So you want to look at that as well because it could really impact your end user experience in this case. You also want to look at some of the infrastructure costs. I mean, this is if you're going to host it yourself, if you're using an API, it doesn't matter. But if you want to run the model and own your own infrastructure, you have to have the right GPU hardware and you want to be able to run your inference. And you also want to look at what you are deploying and hosting options are. Can you deploy it in cloud? Do you have to do this on-prem? Some of the larger organizations, still have on-prem presence. But I mean, uh, uh, unless they are, really some startup or smaller organization, you can also do hybrid. And most of, the major mainstream providers, they do have APIs and SDKs, and they're very compatible. But if we see, some smaller company model provider, they may not have the right SDK. Like if you try OpenAI, everything is available, the libraries, the formatting, the SDKs. But if you go with a smaller, less well, advertised model, you may see that you have to write your own SDK. You have to provide, your own set of libraries from a technical standpoint. The other one is business point of view. We touched on it a little bit earlier. You want to look at, per token pricing, and these vary. There are variations in input tokens and output tokens. Output is usually more expensive than input, so you want to make sure you do your due diligence when it comes to token pricing. If you're going to be hosting this model on your own infrastructure, whether it is on the cloud or elsewhere. What is the cost for it? You want to really look at, the integration cost as well as the development cost. If you want to look at, the total cost of ownership or what we call TCO, it really includes everything: hardware, software, development, even training people to use that from an organizational standpoint. If you are, a business leader and you want to make decisions whether you are going to, what sort of LLM do I want to bring into my organization. Um, for example, we have seen a lot of news in the report that about like 70, 80, 75, 80% of, businesses are not seeing really value from their investment. Because, they bring an LLM and they support it, but they don't really do the training all of the employees. They didn't do the right due diligence. And from a vendor perspective, you want to make sure that what is the type of support you're going to get if you do an open source model. There are very open source like out there. Many open source models are available. You want to make sure if this is community support or vendor support. What does the documentation look like? What is the roadmap? Are they going to get acquired? And then what happens after they get acquired? Are they going to stop supporting the model? um, and you based on that you may pick some smaller company or go with a bigger company that provides you with more support and more compatibility. And finally, we need to look at the security and governance. This is a huge topic by itself. And there you need to read about, the privacy guidelines, security guidelines of each model. And that is where you need to do basically your homework. With a lot of the the paid models or the closed source model. Either you are paying to use the API, or if your company has a custom agreement like an enterprise level agreement with the provider, they generally are not using your data to train their models. But that is something you would want to make sure to check, where the data is, how it is being processed, where is your data stored, who else is using the model, are you sharing your tenant project with some other company, how are the security guidelines implemented, um, is this the like what model we are accessing? Is this dedicated just to your organization or not? And you want to figure out how everything works, how where it is being hosted. You want to see what sort of audit trails you will have. Many cases, the industries are regulated. You have to, for example, in healthcare or finance or manufacturing, you have different regulations, and every industry has their own government regulations that they need to stick to. So this is something that when you run tests on your own data, you can get a little bit of better evaluation whether there is some bias, how is like responsible AI is working in their environment, and do these models have guardrails to prevent toxicity, harmful content, data, and are they protecting against prompt injection attacks? Have they done the right security pen testing on these models or not? So again, this is something that you have to um, work through, like get maybe some reports or provide your pen testing teams. And at the end of the day, you also have to realize that these models are, probabilistic, and how much are they relevant? What is the chances that they could go rogue? So in summary, if you are looking to select, there are some things that you need to think about. Don't You shouldn't just get caught up in whatever is advertised in media or social media or mainstream. And when it comes to AI and LLM, you want to try to shut some noise and really make a data-driven decision based on the concepts that we talked about. You really want to focus on the total cost of the model. Many organizations have ignored this, and the costs are, going out of control. Also, another mistake is not testing with the real data. You have to think about the security considerations. How is your data being used? Who can access the data? And then based on all of these, pick the right model and then rely, really, try to align your roadmap, rather than you would want to work kind of backwards. Start with the business requirement. Do I really need an LLM? It's very easy to get caught up in technology, and everyone is now saying build an agent, use MCP server, etc. Do we really like, what is our use case? How does it help? Do I need a workflow or do I need an agent? Um, and basically, at an organizational level, you would really want to, think about all of these aspects. And then, of course, given how fast things are going, are we even going to be scale this out or not? So yeah, let's now talk about the framework we can actually use to choose the right LLM for our use case. And the selection of the framework has again 4 steps. And basically it starts with the requirement gathering. Once your requirements is gathered, and this is really where we would encourage people to spend most of their time. But when you have, really have good set of requirements, then actually move into the evaluation phase. And this is where you actually test. And once you go through the testing and you have the results of the test and it seems good on your real data, your use case, then we can move on to the deployment phase of the work. Again, going through all of these four phases one by one. Starting with the requirement, you really want to figure out what use cases or what businesses the problem is going to solve for you. What is the specific task is LLM is going to perform? Is this going to use for summarizing text? Is this going to act as a customer service chatbot? Is this going to be used for generating code? You really want to figure out what are those use cases, and you want to define success metrics for each of these use cases. What is good look like without having the right success metrics, it's going to be very hard for you to measure and evaluate your model for the next phase. um, Oops, sorry. um, you would really want to understand what is the real user experience looks like, especially if this is going to be a real-time model where someone's going to interact with it real time. So you would want to look at things like response time, what does the UI, what does the interface look like, and how does this integrate with other systems in your organization. In most cases, these LLMs, you generally have to have the, interact with other systems in your organization. You really want to know what sort of load you're going to expect this model to generate, because it's going to eventually, translate into requests and transactions per seconds and transactions per minute, for example. In real world, unfortunately, we do have constraints. We have a lot to deal with. And in the last couple of years, the number of constraints, number one constraint that we have seen is budget. And with what budget constraint are you dealing with? What is the timeline in terms of, your business stakeholder? When do they need it? And answers to this usually will really help figure out what the timeline look like, understanding the security and compliance requirements. Um, so if it's a regulated industry, those regulations, what are they? How do they translate? And then, what are your technical requirements in terms of infrastructure and being able to understand the skills and capabilities of your team. So if you need to build, some sort of training or enablement program, how does that look like? How do you evaluate it? And so these are very, high evaluation, high level evaluation matrix, and these are just, some samples. So you can, adjust your own or create your own sample of the matrix. And this is simplified version. But at bare minimum, you want to at least have five different categories: performance, cost, latency, security, and support. You can assign different weights to it depending on your use case, depending on your industry. And then you can have selection of different models, A, B, C, open source, closed source, etc. And it could really, you can start evaluating. This is where you put in, the numbers, and then you look at those final scores to make a data-driven decision is what you would want to do. Um, so, and in the pilot, we do pick some of the few edge cases. So when this way you are making you are being able to handle a lot of unexpected errors, and check unexpected behaviors, boundary conditions. You definitely want to involve actual users. And this is some mistake that we have seen many organizations making, is like um, it is only being run by an IT organization or an IT team. And before that, you have to check on a small set of actual users, um, and involve the users early on, get their feedback and sort it, like make it an iterative process to build your testing and evaluation strategy. And in terms of, success, we have, both quantitative and qualitative metrics. There are things you can look at for success. You can look at, response time, how important it is for you, or the cost or accuracy score. You would basically measure those and document those. And these are numbers and easy to measure. And from a qualitative perspective, it's easy. Is it ease of use, for your users? How easy is it to integrate? What is the user satisfaction? Those are some things you would want to make sure as part of, your evaluation. And if things then, go well, you have picked a model, you want to make a decision here. So this is where you want to basically use the evaluation matrix to make a data-driven decision. Looking at the test results, and then you will look at the overall alignment and roadmap, how it fits in the future state. And at this point, you're really looking at the implementation planning or development planning, looking at to see how you can operationalize the model. And how do you come up with the final architecture? How do you work through with different integration requirements? What is the security and governance? Maybe you might need to build a training plan for the employees that you are working with. So you may have to learn some new skills, or get people ramped up. So then you look at the problem at an organizational level in this case. Right, so I will stop sharing. Rohan, do you want to take
Yeah,
over?
thank you so much, Nahid, for taking this up. I think there are lots of questions which are coming your way, by the way, both
Yeah,
in the chat and on the Q&A section.
yeah,
Um, Before we do that, folks, we'll quickly like hand it over to Swati. She is an expert here at Interview Kickstart with regards to career counseling. The Swati will be the one who will be taking the next session, next 10 minutes. Then Nahid will get back while she takes this opportunity to address your questions which have been put in chat and in the Q&A. And then we'll proceed towards the live demo and the remaining section of her content. Over to you, Swati.
Hey, thanks, Rohan. Hope you're all able to see my screen.
Swati, you're not really audible. I think maybe the mouthpiece or something is a bit. I can hear you, but the voice is very feeble.
Is it better?
It's better.
All right. Thanks, Rohan. Hi, everyone. Good evening. Let me just start with a quick introduction. My name is Swati, and I've been working with Interview Kickstart for over past 5.5 years. As my role, what do? I speak to a lot of students like yourselves. I also interact with a lot of instructors on a daily basis. And what we try to do is bridge the gap between our offering and something that is market need at this point in time, so that we bring the best curriculum to you. What I also do is I speak to a lot of people who are enrolled into our program, and we help them out in their successful transition wherever they want to get to. Some people want to get to a fan company, some people are looking to up level themselves, and so on. So that's something that I do. Now let's quickly get started with the presentation that I have. So as I mentioned, as part of Interview Kickstart, there are two things that we do. First, we help you out with interview preparation. So anybody who's looking to get into Fang Plus companies or the tier one companies, any company that is of your dream company, we can help you out with that. Second thing that we are doing at this point in time is AI upleveling. Like we're having a session right now, AI is the new trend. Everybody is looking to upskill themselves or use AI somewhere in their current role. So that is something that we do as a part of Interview Kickstart. Let me just move on to the next slide. Um, so as I mentioned, we speak to a lot of instructors. So we were looking at a couple of reports, and there was one such report by Future of Jobs 2025. And what they mentioned is, in the next couple of months, AI, ML, and data science jobs are going to be the top 3 growing job roles among a lot of others. And that is being seen in the report as well. If you see AI, ML, data science role, they have gone up by 4.7x, which is huge. What's also happening with this is a lot of data engineering roles are also growing, because as there is a huge demand for data scientists, ML engineers, there is also a lot of requirements for data engineers to build those data pipelines. So that is something that's happening. Now, what does happen when there is a lot of demand but shortage of people who can actually fill those roles? The compensation goes really up. You can see that clearly in the graph. I'll just give you all maybe 2 seconds to go through it. If you start with, say, software engineer one, you see the compensation, base compensation is typically 20 LPA, there's 1 LPA gap. However, the moment you go to L6 or L7, you can see the gap is huge. It's 10 LPA. If you go to L7, it's 35 LPA at this point in time, and it is only increasing. Because what we also read is Westcop report. At this point in time, there is only one Gen AI engineer to fill 10 roles. So you can imagine the kind of deficit of talent that we have. That also presents a huge opportunity for you all to actually upskill yourself and maybe fill some of these job roles. All right. This is again a graph that represents the requirement of AI ML skills in open roles. As you can see, in data engineering, we are seeing a huge demand at this point in time. 51.5% of job roles are asking for AI ML knowledge. In software engineering, you can see that 36.9, engineering manager 26.9, and so on. So what we do is we also speak to a lot of folks, and we understand that at this point in time, it's a challenge to understand what would be a right roadmap for you. So we're hoping to solve that for you. But before we move on and get into the details about what does IK do, I just have one sample example. I've taken a sample of software engineering and just want to show you all that how a lot of these companies are asking you to be AI enabled in your role. So if you see, there are two open positions here. One is for LinkedIn and the other one is for Microsoft. So the first opening is for staff software engineer. The second one is for software engineer. Now, what they're looking for is AI ML integration. If you see in the Microsoft job opening, it says you will be joining the inference team that builds model serving platform for large models, including OpenAI, GenAI models. So this is what the companies need at this point in time. Now, how do you select where should you go to? Let me just move on to the next slide. So now, who you are. If you're somebody who, say, has 0 to 5 years of experience, you're new to mid